Reverberation is the result of sound waves bouncing off many surfaces, such as the walls, the floor, or the ceiling. It is actually present in any sound we hear in our everyday life, so we don't always pay attention to it. But when a sound is played in a room, or in any space really, we perceive the direct sound from the source, followed by the reflection of that sound of the surfaces in that space. When the time between these reflections is long enough, it creates an echo effect, where we can hear the original sound repeating several times. This is what the delay does, which is an effect we'll see in the next video. But when the time between these reflections is short and scattered enough, they blend and create kind of a trail of sound. This is what we call reverb. So, reverb effects are audio effects that are designed to emulate this type of reflections, and it is good to place your sound in a particular space. In a studio environment, when we record an instrument or a voice, we often try to eliminate as much of these reflections as we can, with acoustic treatment like foam panels for example. But in the context of a song, a dry recording without any reverb can sound thin or unnatural. So why do we tend to eliminate all this natural reverb when we are recording in a studio? Well, it's because it allows you to clean your recording before it goes to a reverb. Because a reverb would take all the frequencies in the sound and kind of scatter them in the frequency spectrum. So if you can remove unwanted frequencies or noises before applying any reverb effect, it would be easier to have a clean mix. So reverb effects are designed to emulate the reflections of a sound in a space, and there are several ways to achieve that. Chamber reverbs were originally made by placing a speaker and a microphone in a room. That way you would directly record the sound reverberating in a real room. The name of the effect would then change depending on the size of the room. Studio reverb for a very short one, a room reverb when it's a little longer, up to a hall reverb for a very big space. Nowadays, it is way easier to recreate this effect with softwares, which we'll get into in a minute. Or you could create a plate reverb by playing a sound through a metallic sheet and then recording the resulting sound with contact microphones attached to the plate. Basically, imagine a speaker that instead of vibrating a cone to produce waves of different air pressures, it makes a big sheet of metal vibrate, so the metal sheet will distort, altering the sound in the process, and that creates an effect very similar to the reverb of a room. But there are still some differences between a plate reverb and a chamber reverb though. Sound travels way faster in metal than in air, particularly for high frequencies. So with a plate reverb, which makes the sound travel in metal, you will hear the higher frequencies slightly before the lower ones. And because of a psychoacoustic phenomenon called precedence, we hear the overall sound as brighter. So plate reverbs are cool to make something sound brighter without actually boosting the high frequencies. And that's why it's used a lot on vocals or acoustic guitars, for example. And the fact that sound travels in metal faster also makes the time between each echo way shorter, which makes the reverb more dense and also more consistent over time. In a similar way, you could run the sound through a metallic coil to create a spring reverb, which is a popular effect for guitars. When the sound travels through a spring, it bounces back and forth, which creates a succession of rapid echoes. And it's the succession of these echoes that makes the tail of the sound, that make it sound like a reverb. The fact that the sound needs to travel the distance of the spring back and forth to create each echo makes the time between each echo longer, which gives the spring reverb kind of a bouncy quality. The way the spring vibrates also affects the frequency response of the signal, which gives the spring reverb its particular sound. In fact, sound waves need to travel along the coils of the spring, so they move the coils one after the other to move forward. And low frequencies with their longer wavelength can make several coils move at the same time, which allows lower frequencies to travel faster than higher ones, which means we'll hear the lower frequency before the high ones, so the resulting sound will seem darker. Now, not everybody have the space or equipment to create this kind of reverbs mechanically, and this is where softwares come into play. There are actually two ways of creating a reverb with softwares. There are algorithmic reverbs and convolution reverbs. Algorithmic reverbs are softwares that work only from their own internal algorithms, so they are generally less accurate when it comes to realism, but they are also lighter on the CPU. They can be designed to replicate a chamber reverb, a plate reverb or a spring reverb, but they can also be designed to do more creative stuff, like a shimmer reverb that pitches up every echo slightly, so the trail of the reverb would go up in pitch, giving a brighter tone. or the other way around, the trail could go down in pitch to give a darker tone. Now, convolution reverbs, on the other hand, work in pair with a particular type of file called impulse response, which is like the fingerprints of a room or a piece of equipment that exists in the real world. Basically, to create an impulse response of a room, for example, you take a very short impulse sound, like one sample long, a very short burst of white noise. Then you play it in the room you want to create an impulse response file for, and you record the reverb with a microphone. This recording you made is the impulse response. Then all you have to do is to put it in a convolution reverb, and it will emulate quite accurately the reverb of the room you recorded in. Convolution reverbs are actually the most accurate when it comes to recreating reverb from a real-world place. And the beauty of it is that you can also generate impulse responses for other equipments than a room. You could create an IR file for a spring reverb, for a plate reverb, or even for guitar amplifiers. Softwares that emulate guitar cabs use the exact same technology. And it goes even deeper, because impulse responses are typically wave files, so you could load your own sounds in a convolution reverb to see how it reacts, and use it as a sound design tool. This is a deep rabbit hole to explore, so I may do that in a separate video, as this one will be quite long already. So, in Ableton you can find a free convolution reverb as a Max for Live device simply called Convolution Reverb. It's part of the essential pack that comes with it, and it already has a lot of impulse responses in it, but you can still add your own if you want to have more, or if you want to use it as a guitar cab emulator. So how do we actually use these reverbs? We are going to see the main parameters you're likely to see on every reverb and how they affect the sound, and then we'll see some tips and tricks to get the most out of them. I'll be using Ableton stock reverb for the demonstration, which is an algorithm reverb. So there you have a dry-wet knob that allows you to mix the dry signal, not affected by the reverb, with the wet signal. And then the main parameter of any reverb, I guess, would be the decay time, which will set the length of the reverberation. Next to that, you also have a stereo knob to make the reverb sound more or less wide in the stereo field. And a size knob to emulate either a small room or a bigger room. So generally, a smaller size would work fine with a smaller decay time, and a bigger size would work fine with a bigger decay time. But you could also make more surreal effects with a small size with a big decay time, for example. Note that this reverb also have a setting of economic, medium and high quality that can change the way the reverb sounds. So don't hesitate to play with that, as even on high quality it is quite CPU friendly. Another parameter you're likely to see on any reverb effect is the pre-delay knob. It is basically a delay time between the dry signal and the first echo of the reverb. A short pre-delay will make the sound appear closer to the walls of the simulated room, and a longer pre-delay will make the source of the sound appear farther away from those walls and closer to the listener. And lastly, I want to talk about the reflect and diffusion knobs. The reflect knob, often called early reflection, sets the level of the first group of echoes. These early reflections are usually more defined than the rest of the tail. It sounds kind of more like a delay than an actual reverb. So turning up the early reflection knob usually works better on sustained sounds like vocals or pads. And turning it down places the sound further back in the room, which often sounds better for more percussive sounds. And the diffuse knob sets the level of the tail, so you can have more control over the balance between the tail and the early reflections. So I won't go in details in all the features this reverb has because it is not a tutorial on this particular reverb, but instead let's see some tips on how you can use reverbs in general. So how to use reverb? One thing to keep in mind is that every frequency will be scattered in the frequency spectrum once it's processed by a reverb. So it is a good idea to place an EQ before the reverb to get rid of problematic frequencies. It's always easier to clean a sound before the reverb than after, and you can also put an EQ after the reverb to make it sound as you like. That's why in Ableton's Reverb you have two simple EQs, one to filter the sound before the effect and one after. Reverb is a nice effect to make a sound wider by putting the sound in a space, but when you use reverb on a sound, it also makes it appear more distant, farther away from you, from the listener. So it is a balance you want to keep in mind while using reverbs. One thing I like to do to have more control over the reverb is to create a parallel track for it. So basically in Ableton, I would create an effect track with two chains. One chain with no effect, that would be my dry channel, and one chain with the reverb set on 100% wet. Then I would play with the volume of each chain to set the balance I want. You can also link one of the macro knobs to the chain selector to create a new dry-wet knob for this effect track. Having these two separate chains allows you to process the dry sound and the wet sound separately and more freely. For instance, you can put a compressor on the wet channel to make the reverb a bit thicker. Or you can even use sidechain compression and take the dry signal to trigger the compressor. This way, the reverb will appear only after the dry signal has stopped playing, because the dry signal will duck down the reverb when it plays. And then you can play with the release of this compressor to adjust how fast the reverb comes back in after the dry sound has stopped playing. You can also add your own EQs before and after the reverb, which will give you more control than a built-in EQ. And it is really useful to control the color of your reverb so it would fit the mix better. For example, if you have some prominent frequencies in the original sound that can cause problems once it's put through a reverb, you can tame them beforehand. And then the second EQ is there to shape the overall color of the reverb. Speaking about EQ, I often prefer to cut the lows in the reverb, as reverb on low frequencies tend to cause chaos in a mix, but there are some exceptions to that. You can also use a reverb on a return track, so you could send any of the tracks of your song to that reverb and each one with a different value. So you would have all your tracks unaffected by the reverb, layered with the reverb version of themselves. And because these reverb versions all come from the same reverb, it's a good way to place all your instruments in the same space. And this common space, these common acoustic characteristics, would tie everything together in a coherent way. And because this return track is also its own chain, you can also use EQs, compressors and other effects to shape this reverb as you like. These all work in the context of both mixing and sound design. But on the sound design side, you can also simply use a reverb to add a tail to a very short sound, like a very short drum sound to make it a bit longer. Some reverbs also have a freeze option. It will hold the sound of the reverb so you can have a sound that sustains forever. It's cool to have a long sound to resample and to use as a starting point for a new sound design. Another thing I like to do that is less conventional and that I took from techno music is to use parallel reverb on a kick. Basically, you would create two parallel chains with an effect track, just like we did before with a dry channel and a reverb on the wet channel, and then you want to add a low pass filter before the reverb, so it will affect only the low frequencies. This is a good trick to add some boom and some oomph to a kick, and I found it sometimes more effective than parallel saturation or parallel compression to give this extra thickness I wanted. This is one of those weird tricks, as generally putting a reverb on low frequencies is considered a bad practice because you want to have the bottom end of your mix in mono, but you can still add a utility effect and drag the width knob to 0 to make it mono again. And with this one, it can be good to use the sidechain compression triggered by the dry signal. This way you would hear the rumble after the kick has stopped playing to keep it a bit cleaner. The thing to keep in mind here is that it would add low frequencies, so if you have a bass playing in the same range, the two could clash. So you could keep this trick for a track where there's not too much happening in the very low end, or you could have an EQ that cuts the low end of your bass, so it doesn't clash too much with it. One last thing I wanted to add is a very popular trick on how to use the pre-delay. I think it's too important not to include it here. Let's take this chain we've made for the kick as an example. We could use the pre-delay to make the reverb come a bit later, to add this bouncy feel to it. And sometimes you want to have this pre-delay time synced to your tempo, so it would kick in after exactly a 16th note or 8th note. And if we want to do that, we need to find how many milliseconds exactly is that 16th or 8th note. Here's how to calculate it easily. Your BPM gives you the number of beats that are in 1 minute. These are the quarter notes. You also know that in a minute there are 60 seconds. That's 60,000 milliseconds per minute. So we need to divide this 60,000 milliseconds by your BPM to have the length of one quarter note. At 120 BPM, the quarter note is 500 milliseconds. Divide that by 2 and you have the length of an 8th note, that's 250 milliseconds. And divide that by 2 again and you have the length of a 16th note, that's 125 milliseconds. Now let's hear how the reverb sounds with a pre-delay of a 16th note. So I'll put 125 milliseconds here. Now with a pre-delay of an 8th note, so that's 250 milliseconds. So you can use this pre-delay knob to add some bounciness to your tracks. Using it in this way essentially makes a slapback delay effect, which is something we'll see very soon in the next video when we talk about delay effects. In the meantime, thank you very much for watching, take care, and I'll see you all next time.